The G5-RSS is our new generation of modular DC systems. Over 70 years of combined development time has been invested into its new silicon carbide design. Ultrafast dynamics make it ideal for testing devices that experience transients like high-speed drives and motors. A current step between 90% sourcing and 90% sinking can be less than 25 microseconds, with a small overshoot before settling, even for this megawatt scale system shown on screen. Users can optimize the controller for a more regulated response with no overshoot. This example shows a 1000 amp current step in under 300 microseconds. The bidirectional G5-RSS is widely adopted across industries, including automotive, aerospace, marine, off-highway, and many other sectors that require highly accurate programmable power systems. Individual G5-RSS modules are available with nominals from 9 kilowatts to 54 kilowatts at 80 volts to 1500 volts. Each unit has a wide auto-ranging output, allowing testing at maximum power even when operating down to a third of the power system's nominal voltage. Each G5-RSS is able to operate independently, or can be combined with others in parallel master-slave, matrix configurations of series strings in parallel, or series-only configurations. Modules can operate in series around a midpoint Earth to provide a positive and negative voltage. The nominated master controls all the modules that form the system. This differs from power systems, which use a filter to split a single output to achieve positive and negative voltage, which may result in issues with earthing and voltage imbalances to the test piece. If the device under test creates an unbalanced demand, the modules will automatically adapt their outputs to produce overall values set on the master unit without exceeding any programmed limits. Systems can be reconfigured, expanded or broken up as required, making this modular approach especially useful for test houses and research labs that regularly test different sized power devices. Up to 120 modules can be combined to allow for outputs up to 3000 volts, tens of thousands of amps, and 6 megawatts. The output can be switched between high and low capacitance states to optimize for a smooth output or faster response speeds. A second current range is provided, allowing a single power system to conduct precise work at both high and low powers, such as when testing a motor at varying speeds. At 10% of a system's nominal current, accuracies up to 0.003% are possible. When researching batteries, many users also choose to include the optional voltage matching function with reverse polarity protection. This prevents any large current surge on initial connection by matching the device voltage before closing the circuit. Should the battery have been accidentally connected with reverse polarity, the voltage can never be matched, and therefore the DC contactor does not close, preventing accidental damage. Standard interfaces include Ethernet and USB. For users interested in real-time or power hardware in the loop integrations, a 16-bit isolated analog is also standard. There's an optional SFP interface for high-speed digital data transmission, which allows integration using the Aurora protocol to support real-time controllers such as OPAL-RT, Typhoon, SpeedGoat, and RTDS. Like the analog interface, the SFP operates at 48 kHz. The analog interface has user reconfigurable pins which allow it to be honed for your specific P-HIL setup. The interface can still measure data even when another interface is controlling the system. Other optional interfaces include high-speed multi-protocol CAN. It operates at 1 kHz with up to 100 user configurable messages. EtherCAT, which is particularly popular with industrial customers, and a lockable touchscreen front panel, which allows for values to be set and viewed locally. An intuitive operating GUI is provided with each module to simplify setup for users. It includes an embedded 8-channel scope, which allows users to visualize and record live test data with an adjustable sampling rate at up to 48 kHz. The software also provides a variety of programming features and second-level parameters ideal for optimizing test processes and protecting sensitive test pieces. A .NET API is provided to simplify the integration into third-party control and measurement software platforms such as LabVIEW and MATLAB. The API can be used to integrate with programming languages including Python and C#. For machines not operating on Windows, a REST API and pre-programmed Skippy commands are also available. A selection of application-specific software is available to aid research. By utilising the unit's optional embedded function generator, users can set a current ripple at up to 10 kHz without needing an external waveform generator, a feature commonly used in electrochemical impedance spectroscopy testing. It also includes a sweep function which allows easy programming of repeated waveforms with varying frequency and/or amplitude. Parametric programming is also possible with the application area programming option, where instead of the time axis, an input variable is used, useful when emulating fuel cells. Other optional software includes BATSIM, to emulate the electrical characteristics of energy storage devices. Users can define variables such as battery chemistry, number of cells in series and parallel, along with rated capacity and internal resistance levels to simulate aging batteries. BAT control for cycling batteries. The GUI allows for automated testing of common charging programs. Set points of the tests can be automatically adjusted based on time or measured variables. The package is also used to cycle electric drives. Previous data from a test track can be imported and recreated to simulate a real-world drive-in test inside a lab environment. Solar array simulation is available with pre-installed tests to EN50530 and Sandia. Users can make adaptations to the standard models to optimize the tests for specific solar inverters. Values which can be manipulated include irradiance, temperature, amplitude, or input scaling. A host of safety features are available. Modules can be built with an integrated safety relay, providing isolation of the module's primary side when linking out to an external safety system. This allows connection to an external stop button, rated up to performance level C. PLE is attainable with optional cabinet integrations and safety relay extension. Other cabinet safety options include a lockable mains isolator, passive indication of any residual DC voltage, a panel-mounted emergency stop, and isolation monitoring. A DC switch panel can be provided for multi-module cabinet integration to minimize potential user errors and simplify reconfiguration. The switch panel links the DC bars of each of the G5-RSS modules to one connection point. Switching between parallel, series and matrix configurations is done simply by changing mechanical links within the panel. Project-specific automated configuration switching is also possible. Modules can be integrated into either static or mobile lab racks or flight cases. Enclosures are available with ratings up to IP54, offering protection against water splashes in test environments which have fire suppression equipment. Liquid-cooled cabinets are also available where floor space is at a premium. The G5 series can also be built as unidirectional DC sources or regenerative electronic loads. Rental options are also available up to 324 kilowatts, 2000 volts, and 2700 amps. For more details about the power of the G5-RSS, please view the product page and datasheets available on our website, or speak to one of our experts by phone or email.